where would the what would we do? What's the smallest number there?
67.
57?
67.
67. Okay. So 67. What's the biggest number?
74.
74.
All right, so we have 67, 60. So I can actually make these lines a little bit more separate. So 67, 68.
Mister, I have a question.
Go ahead.
You need to copy the exercise.
No, just your work. Just your work. Don't copy the exercise. That would be
Okay.
that would be really mean or rude or whatever you want to call it. All right, so 70. We put. What color do you want me to put the dots in?
Pink.
Blue.
All right, we're going with pink. Or do you want rainbow color?
That one. That sounds good.
Okay, so we're gonna go with rainbow color. Fair enough. So we're gonna have 70, right? 72. 71. 70. 69. 68. 70. 71. 67. 71. 70. 74. 69. 68. 71. 71. 71. 72. 69. 71. 68. 67. 73. 74. 70. 71. 69. 68. Is that hard, guys?
Mister, you skipped a 73 and a 69 in the beginning.
Okay. Is that better now? Every time I look to the left and look at the attendance reform that Mongo and Allen showed us has really worked in preventing unwanted kids. Okay, I have removed a few myself, but they sometimes use made-up names. If it's a weird name, I do not enter them. Okay. All right. Is that hard to do, guys?
Absolutely not.
It's easy, right? Like there shouldn't be an issue doing this. Joshua, are you good?
Mister, can you show
Yes.
us number 3?
Yeah, I'm good, mister.
Okay. I'll get to number 3 right now. Oh, you want to see it, right? You're working on the problems?
Yeah, I just need to do number 3.
All right. So I'm sorry that. Here we go. I'm gonna zoom in now to number 2. So there we go. I'm gonna go ahead and erase number. No, I don't have to erase. I can just do it down. Okay. Stem and leaf plot, guys. Talk to me. What's the smallest number there?
127.
So what's our smallest? Oh my gosh! Wait. Let me look at that. Our smallest stem would be 12, right? And what's our biggest number?
287.
Oh my gosh! 21, 21, 22, 23, 24, 25, 26, 27, 28. 287 was the biggest one?
Yeah.
So you see, sometimes it's not very good to do the stem and leaf plot, unfortunately. Not all the time, but sometimes. So here we go, stem and leaf. Now, before I begin, let me go ahead and do a key for this. Remember, we had to do a key, right?
Yep.
I'm going to say 13/2 means 132. Fair enough? Does that key adequately represent how to read this?
Mister, do we always have to do a key?
Always. Always, you gotta tell your reader what it means, what your graph means. So let's take a look at the first one. It says 149, so here's the 9. And then we have 167, here's a 7. Here's 162, here's a 2. We got 127, here's a 7. We got 130, 180, 160, 167, 221, 145, 137, 194, 207, 150, 254, 262, 244, 287, 137, 204, 166, 174, 180, 151. That's it. If I didn't miss any numbers because I'm looking up and down, then that's good. Make sense, guys? Questions or concerns? I use my iPad for notes and Zoom, so when I'm done taking notes, it turns my camera off on Zoom. It's okay. It's okay. Just make sure that since you're doing that, you'll be able to share your notes with me. But you can't just screenshot it because that's gonna be your grade today. A screenshot of your notes. Okay. Are we good, guys? Can I move on?
Yeah.
Okay. Okay. So we're gonna do number 3, which probably is the most difficult one to do. Actually, let's go ahead and let's do number 3. Let's get the difficult one, per se, done. So I'm gonna zoom in on it here. And in class, it's hard to get everybody to being a compass and protractor. So what I'm gonna do is I'm gonna just fill out the chart and determine the angles. They want a pie chart. So we have to figure out the angles. That's what we're doing. So the first thing we have to do is we have to find the relative frequency. Okay? But to figure that out, we have to find the sum of the frequencies. Has anybody found the sum? Huh?
400.
400?
Yeah.
Okay. So if you add 69 plus 124 plus 72 plus 32 plus 103, that's 400. So what's 69 divided by 400?
It's 0.1725.
All right, so let's go ahead and put 1.17. Let's keep the number simple. And then the next one is 124 divided by 400. And we'll zoom in a little bit. It's 0.31. So that's a nice number. It's not that nice, but it's nice enough. And then 72 divided by 400.
0.18.
0.18. So glad I did 2 decimal places at the beginning. And the next one is 32 divided by 400, right?
0.08.
0.08. And the last one, 103 divided by 400.
It's 0.2575.
So 0.26. Do we agree?
Yeah, rounded.
Okay, great. So now let's just check our relative frequencies. 0.17 plus 0.31 plus 0.18 plus 0.08 plus 0.26. And I get 1. Lovely. Now we got to find the central angle. And all we have to do to find the central angle is we take 360 times 0.17. We take 360 times 0.31. We take 360 times 0.18. We take 360 and times 0.08 and 360 times 0.26. So I'm gonna go ahead and do that here. I got 61.2 degrees. I'm gonna go ahead and write 61 degrees here. 360 times 0.31, that's 111.6. So I'm gonna write 112 degrees. I'm gonna take 360 times 0.18, that's 64.8. I'm gonna go ahead and say 65 degrees. 360 times
So you always round to the
0.08.
nearest whole number?
You could do it that way. Yes, you can, but do it correctly. Don't do it like we did class with. Do it like you would normally do it. So just think about if you're using a protractor, you're not gonna put a protractor 28.8. You're gonna put 29. But because we're rounding, go ahead. Go ahead.
Oh, no, that's everything. Mister.
Okay. The thing is, when we're rounding, because we're rounding, sometimes we might not get, when we add up all the angles, we might not get 360, you know? So then you just make your adjustments. But I got here the sum of the angles, I got 361. And that happens because of rounding. It should be 360, but it's a little bit off, but that's okay. I could make one a little bit less or another one a little bit more because we're rounding. And so technically you would be done. For me. Now, if you had a compass and you would make your circle. You would go ahead and go like this. Then you go for newspaper ads or whatever that is. It says 61 degrees. So, like, I think roughly like that, something like that. Probably a little
Mister,
bit more. Yes.
didn't you miss the 1.18?
What's 1.18? It's 0.18.
Oh, oh,
Yeah, I
oh.
can see 0.18. So 61 degrees is like around here. And then you would write here 31%, and you would put it as newspaper. Newspaper. And then online services is 31 degrees. 112 degrees. So now I'm going to turn my circle to the side. It's going to be more than 90, but a little bit more than 90. So I'll go like this. I mean, I'm probably a little bit off, but I'm eyeballing this. So this is 17% here. My bad. 17%. And this is 31%. And this is online services. And the next one is 65 degrees. So it's a little bit more than this. So I mean, again, if I had a protractor, it would be nicer. So 18% here, and this would represent executive search firms. So executive search firms. The next one is 29 degrees. So that's not that much. All right. And that would be like 8%. You don't have to do this. I'm happy if you just do the chart. That's mailings. And the last one, remaining one, will be 26% or 25%, something like that. You might want to make an adjustment on one of them. Let's just, whatever. We'll leave it like that, networking. But you make an adjustment so it adds up no, that's right. Degrees, you don't need to worry about. The percents we added up to 1. So we're good with this. And that's something like it's going to look like that. Does that make sense, guys? More or less?
Mister, how did you get 361 in the end?
Because of the rounding. I rounded them to the nearest whole number. So every once in a while, you'll get, instead of getting 360, you'll get like 361 or maybe 359. It depends how you round it. If you take 61 plus 112 plus 65 plus 29 plus 94, you get 361.
We don't have to worry about doing the pie chart, right?
No, you don't have to worry about that because you're not gonna bring a protractor and compass. You know, it's just not gonna happen. I know it's not gonna happen. I already tried that many years ago, and like you have like 7 kids bring it, and like now your test is ruined. Okay. Who's texting me? Teachers are having a fit about kids now. Okay, okay. All right, so can I move on, guys? Look at number 4. They want you to do a time series. Okay? So we have there the years 1965, Then you have 1985. Then you have 1990. Time always goes on the horizontal. Then you have 1995. Then you have 2000. And then the percent of smokers is up to 42. So I'll go ahead and go, I don't know, I'm going to be a little bit lazy. 20%, 30%, 40%, 50%. Okay, so what am I supposed to do now? Is this a bar graph? And let me go ahead and scroll this down because I know you can't see it. Is this a bar graph?
No.
No. Isn't the time series, it's going to be what? It's going to be a line graph, right? Okay, so what do I do now? 1965 has how much?
42%.
42. And then the next one is 30%, right?
Yep.
And then the next one?
25.
25. This is a little bit low, but whatever. 25. And the next one?
25.
And then the last one?
23.
At the end logo, the teachers. All right, so is this correct? Is this graph correct? Do you see anything wrong with it?
Mister, does this graph have to be in our notes?
Yes, yes, please. Do you see anything wrong with what I did here?
No.
No, let me tell you what I did wrong. From here to here, how many years is there? From here to here, how much years is there?
20.
Ah, so you see what I'm saying?
Oh.
Ah, so this is what you guys will do on the test. You'll do that, and then you, Mister, you marked it wrong. I'm like, your scale on the x-axis. Well, you know what I meant. I'm like, no, we talked about it. So I have to pick a scale. I'm gonna have to stick to it. So if I'm gonna redo this problem correctly now, I have to worry about that scale. Some people say no. I think it's very important to have, to have scale because we're graphing after all. So, yes, Mama. I'm not drawing, Mama. Yes. Oh my. Oh, oh. All right. Thank you, Mama. I love you. Just go, leave. I don't know. I don't know. What? You hate me.
Is
Well,
that a leaf?
yeah, I give her everything, man. I give her yogurt. I give her water. I give her food. I buy her McDonald's, and she hates me. When was the last time you told your parents you hate them?
You give her love?
Oh my gosh, I don't. I even play Minecraft for her.
Damn, that
sleeps.
says a lot.
She sleeps next to me all night and doesn't let me sleep.
Minecraft is not the definition of love, Jimmy.
Remember, it's a coaster in class, especially when we're recording. All right, 1965. You see what I did now? All I did was I put my scale, and now for 1985, it's 30. All right. In 1990, it's what? 25. Right? You see that? You do the same thing, but now, because of your scale, the scaling you just did, now you see how the lines look? Everything after 1985 looks the same, but we've changed how it plots out. Does that make sense, guys? Yes or no, maybe?
Yeah, it
Yeah.
makes sense.
Super easy, right?
So, Mister, the one you did before, was it wrong?
Yes, it was wrong. It was wrong. It was wrong because I didn't have a scale, consistent scale for my years, my horizontal axis. And remember, for time series starts, you're forced to have years. Okay. Look at number 5, and this is the last problem we're doing. And then I want to go ahead and just update your grades. I'll be posting this video after I make sure no faces showed up later on in the day. So take a look at number 5. It says that we're going to do a scatter plot. So we have infant mortality. And we have life expectancy. I'll just write LE. And so one is your X, one is your Y. So if you look at your infant mortality, it goes from, and this is kind of important, goes from 35 to basically to 199 to 200. So I'm going to go ahead and pick a scale here of 50. Now, you know what? 30s. Let's do 30s. 30, 60, 90, 120, 150, 180, 210. And then life expectancy goes up to 70. So I'm going to go in 10s. 10, 20, 30, 40, 50, 60, 70. So 63 is like around here. And then you have 45, which is here. So wherever those two meets, it's like graphing X and Y in algebra. Right? And then the next one's 199, 31. So we go like around where 199 would be, like around here. And then we go to 31 and we put a dot. So I'm gonna go ahead and put the dot there. 71, just a little bit higher, and 51. So that's just over here, somewhere here. 61, 47, like around here. Wait, that was tough. Like here. 67, 39. And then 35, 70. And then 194, 37. And so 37 is like here. And that's a scatter plot, guys. That's all it is.